Hi and welcome to the ninth video on kinematics. In this video we will have free fall and we'll get to use the equations of kinematics. We have a bunch of questions here. Question A asking us how long, we have questions asking us about time, how high, questions asking us about the height or the distance, how long again, a certain time, how long, time again, velocity. And so we'll be finding all those things in this video. The question reads, a ball is thrown vertically upwards with an initial speed of 25 meters per second from a point located 25 meters above the ground. Let's try to visualize the situation. So we have sort of a building here, and this is 25 meters above the ground, and we have a ball that's thrown vertically upwards with a velocity 25 meters per second. Okay, this is all the information we have. Now, what are we asked for? Question A. How long does it take to reach its highest point? Okay, how long does it take to reach its highest point? This is the initial velocity, v naught. When the ball reaches its highest point, it's going to have a final velocity, v is equal to 0. So based on this information, how long does it take to reach its highest point? We're looking for time. Which kinematics equation can we use to find time? Given the initial velocity, given the final velocity, we don't know the displacement. This is the distance it is above the ground. We don't know the displacement that it will have when it reaches a certain point, the highest point. So we only have the initial velocity and the final velocity. And we have acceleration because this is happening against the pull of gravity. So this is negative 9.8 meters per second squared. So we can use this equation. T equals v minus v naught over acceleration. Our final velocity is 0. Our initial velocity is 25 meters per second. We divide this by negative 9.8 meters per square second. We get 2.55 seconds. So the time when the ball reaches its highest point is t equals 2.55 seconds. Let's put it here. T equals 2.55 seconds. So we're done with question A. Question B. How high does the ball rise above its release point? So the question is basically asking us this displacement from here up to here. How high does the ball go? So because we know the time that it takes for the ball to reach the highest point, and we also know the velocity, what else do we know? Its initial velocity, the amount of time, the acceleration. Which equation can we use to get the displacement? Well, I think there are two equations we can use. Let me erase this first. There are two main equations we can use, but we can go ahead and use displacement is equal to v squared minus v naught squared over 2 times acceleration. We know the final velocity is going to be 0 at the highest point, minus the initial velocity is 25, then that's squared, divided by 2 and negative 9.8. This gives us negative 625 divided by negative 19.6, giving us a displacement of 31.9 meters. Let's write it on top as well. So the displacement, or the highest, how high does the ball rise above its release point? This is the highest point that the ball will go. It's 31.9 meters. Next question. How long will it take the bow to reach a point 25 meters above its release point? Now, in this case, what they're asking us, we found that this height is 31.9. They're asking us the time when the bow will reach some height 25 meters above its release point. So we have displacement is equal to 25 meters. The velocity in this case won't be 0. We have the displacement, we have the initial velocity, and we have acceleration. We're being asked to find time. Which equation can we use to get the time? Well, we can use this equation. Displacement is equal to v naught t plus half at squared, because we have displacement, we have initial velocity, we have acceleration. So let's plug everything in. This is 25 is equal to initial velocity is also 25 times time plus half. Our acceleration is negative 9.8, and this is t squared. This gives us 25 is equal to 25t minus, that gives us 4.9 t squared. Now, how do we get t? Since we have a power of 2 in this equation on t, we have to use the quadratic methods. So let's rearrange this so that on one side we have 0. We'll take this and this to the other side. This gives us 4.9 t squared. When 25t is taken on the left, we'll have negative 25t. Then this is plus 25 is equal to 0. Now that we have this, we can label this as A, this will be B, and this will be C. Then we'll use the quadratic formula, which is t is equal to negative b plus or minus square root of b squared minus 4ac divided by 2a. Now, we've gone straight ahead using the quadratic formula because when you look at the first number, 4.9, it's already not a whole number, so we know it doesn't have any factors to it. So negative b. Negative, then our b is negative 25 plus or minus square root of our b is negative 25 squared minus 4. Our a is 4.9 and our c is 25 divided by 2 times what's our a? 4.9. This gives us negative and negative here, 25 plus or minus the square root of 490. This whole thing divided by 9.8. This makes this 25 plus or minus the square root of 135 divided by 9.8. This makes it 25 plus minus 11.6 divided by 9.8, giving us 25 plus 11.6 divided by 9.8, or 25 minus 11.6 divided by 9.8. We'll have 3.73 or 1.34 seconds. So we have t equals this or t equals this. Now, of the two, which one is going to be our final answer? Our final answer is this one, t equals 1.34. Now, you may ask the question, why? When this bow goes up, it will come back down and there will be a certain point there will be 2 points. There will be, these 2 points are both 25 meters above its initial start point. So the first t, the smaller t, which is t equals 1.34, is for when it is going up. The second value of t that we got was when the bow is coming down. Now the question was asking us, how long will it take the bow to reach a point 25 meters above its release point? So we're being asked for the first t. So our answer here is t equals 1.34 seconds. How long does it take the boat to reach a point where it was projected, and how fast is it moving at this point? So essentially what we're being asked here is that how long will it take the bow to go all the way up and come back to a position where it is here. Now, there are two ways of finding this, but because we know the initial amount of time it takes for the bow to get to the final position or the highest point, which we got in question A. So the amount of time it takes for it to reach the highest point is the exact same amount of time it would take to come back to this point. So if this is T1 and this side is T2, it means that T, the total time it takes to go from this point and come back here, is equal to T1 plus T2. This gives us 2.55 seconds, which we got from A, plus 2.55. This gives us 5.1 seconds. Now, there's another way we can get this same amount of time. We know to say at this point, when the bow reaches back at this point, the displacement is 0. Because displacement also has direction, if it goes up and comes back to this same point, it will have a displacement of 0. So, in that case, we can use one of the kinematic equations. We can use S equals V naught T plus half AT squared. We have displacement, which is 0. Initial velocity is 25. Time is what we are looking for. Plus half. Our A is negative 9.8. Then we have T squared. We simplify this. We have 0 is equal to 25T minus 4.9T squared. At this point, we can factor out T so that we have T open 25 minus 4.9T. We'll say T is equal to 0 or 25 minus 4.9T is equal to 0. We take the 4.9T the other side. We get this. Divide both sides by 4.9. We get T is equal to which is exactly what we got there. So that's one way of doing it. And so our value of time is T is equal to 5.1 seconds. With what value does it strike the ground? So they're asking us for the value of velocity when it comes back all the way down. Now, at this point, what do we know about this position? We know that the displacement is equal to 25 meters because it started at a height of 25 and it goes down to the bottom, which is at 0. Now, here's the difference. Because this is displacement, it has to have direction. If we take 25 as the displacement, remember earlier we had 25 as the displacement and it was going upwards. It was somewhere here. we have to differentiate between the two displacements. So if we take this, the baseline where this object is, as the 0 reference point, we'll take the displacement coming downwards as negative and the one on top as positive. That means that we have to take our displacement as negative 25. What else do we have? Acceleration is negative 9.8 meters per second squared. It's still negative because initially the ball is going upwards. The initial velocity remains the same, which is 25 meters per second, because it's going upwards initially, but the final displacement has to be negative 25 meters. Okay, so can we find the velocity and what's the best equation to do so? And one thing we forgot is how long does it take the ball to reach a point where it was projected, and how fast is it moving at this point? Well, we got the time that it took, which was 5.1 seconds. So we'll use v equals v naught plus at, the initial velocity 25, acceleration negative 9.8, and the time 5.1 seconds. If we punch all this in, we'll get about negative 24.95, which is approximately equal to negative 25 meters per second. We'll use v squared is equal to v naught squared plus 2as. V squared is what we're looking for. Initial velocity is 25 plus 2, our acceleration is negative 9.8, and our displacement is negative 25. We get 625 here, plus, this is negative and negative, so it stays as plus 490. This gives us, now remember that this is v squared. To get v, we have to take a square root both sides, leaving us with v equals 33.4 meters per second.